Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which I will go through everything you need to know for the final exam in a couple of weeks. So it covers everything that we've done this semester, and the 5 topics we've covered are on your screen now. So I'm going to go through these one by one, starting with simple interest. So recall that when you invest money with a bank, they pay you money to do that. That money you earn is called interest. Similarly, when you borrow money from a bank, you have to pay them back extra money. So if you borrow $5,000 from a bank, you don't pay them back $5,000, you pay back $5,000 plus a bit extra. That extra money is also called interest. Now, whether the interest is money earned from investing or extra money owed when you're borrowing, the calculation for interest is always the same. So we're going to do the questions the same way, whether they're talking about borrowing or investing. Now, when you do borrow money from a bank or invest with a bank, they don't have a fixed fee. They don't say it costs you $1,000 to borrow or you will get $1,000 if you invest. Instead, they offer you a percentage of the principal. So remember, the principal amount is the amount you start with. So if you borrow money, the principal is how much you originally borrowed. And if you invest money, the principal is the amount you initially invested. So as I said, banks will calculate interest by calculating a percent of the initial amount that you either borrowed or invested. So that's what P will stand for in our formula. So R, they need to give you that interest rate. They tell you what percent of the principal you're either going to have to pay back each year if you borrow, or you will earn each year if you invested. And we also need to know for how long this will be. So they will give you a percentage, or they will charge you a percentage of the principal each year, and you need to work out with them for how many years you're going to either invest the money or for how many years you have to pay back the money. So we're going to calculate I, which is interest. So how do we calculate the interest? What you do is you just find a percentage of the principal. So when you're finding a percent of a quantity, you take the quantity and you times by the percentage over 100. So that is how much you will pay back, or how much you will earn in interest each year. And all you do is times that by the number of years. So I equals PRT over 100. That is the simple interest rate. And again, it is the same formula whether you borrow money or earn money. Let's have a look at an example. Question that's on your screen now. I invest $5,000. I'm given 2.5% of that $5,000 each year by the bank. How much money would I earn after 6 years? So I just need to use the formula I equals PRT over 100. So the interest is P, so that's how much I started with, the initial amount, times the rate, times the time over 100. How easy is that? And you should get $750. So that's how much extra I would have after the 6 years. Now let's look at a question involving borrowing. So please pause and copy down what's on the screen if you need. So let's have a look at this question here. I borrowed $12,000 at 8% per annum for 5 years. What would be my monthly repayment? So this is still on the topic of interest, but not all questions just ask you to find the interest. Sometimes you need to do a bit more. But we are going to start by finding the interest. So we use the formula I equals PRT over 100. Again, we use the same formula even though the last question was about investing and this is about borrowing. So the interest will be how much you started with times the interest rate times the number of years over 100. And so you should get from that 4,800. So what that means is that you, if you borrowed $12,000 at 8% per annum for 5 years, would have to pay back an extra $4,800. Now, when people are calculating the monthly repayment, what they often do as a mistake is they'll say, okay, cool, I'll pay back $4,800, and they just divide that by the number of months. They forget that when you're paying back money, the amount you pay back isn't just the interest. It'd be great if you could just go borrow $50,000 and only pay back the interest. That'd send the banks broke. The amount you pay back is the original amount plus the interest. So, to figure out the monthly repayment, I have to take $16,800 as the amount that I pay back. So that's the total amount I pay back. So the monthly repayment, I'll just call it M, is going to be the total amount I pay back. So you're paying it back over 5 years, and there's 12 months a year. There are 60 months in total. So the monthly repayment is just $16,800 divided by 60, which gives you $280. So what a lot of people will do as a mistake, they'll just divide 4,800 by 60. That's wrong. Here we need to divide the whole amount, $16,800 by 60. So I would have to pay back $280 per month so that this loan was paid back in 5 years. So the last thing I need to show you now is finding P, R, or T when you already know the interest. So let's look at the question here. I invest $5,000 for 18 months. What interest rate do I require for my investment to grow to $6,000? So in this case, we already know what the interest is. We can figure that out very easily, which I'll do in a second. But we're actually asked what interest rate. That's what we're trying to find. So here, we're not finding I, we're finding R. But you can still use the same formula, I equals PRT over 100. You can use this same formula to find P, R, or T. If we were finding P or T, we do the question the exact same way as I'm about to do it. What you do is you substitute into the formula everything you do know, then rearrange to figure out the one thing that you don't know. So in this question, if I start with $5,000, then clearly the principal is 5,000, easy as. So T, I'm just going to put 18 for 18 months. But wait a minute. What we usually want is the rate per year. So that's important. When you're using this formula, whether you're finding I, whether you're finding P or whatever, R and T need to be in the same units. If they're not, you need to change one of them. Usually, R will be per annum, per year, in almost all the questions you do. So if T is not per year, as it is here it's 18 months, then you need to change it to years. So T is 18 months, I change it to years by dividing by 12. You should all know that 18 months is 1.5 years. So I'm going to put 1.5 into the formula. Now, the other thing I need to find in order to calculate R is I. I need to know I. Think of this as an equation with 1, 2, 3, 4 variables, I, P, R, and T. You need to know 3 of them to find the 4th. So what's the interest? Well, I started at 5,000. I want it to grow to 6,000. So the interest I want to earn is 1,000. So what I'm going to do is I'm going to substitute I is 1,000, T is 1.5, and P is 5,000 into the equation in red. So I have I equals P times R, so R is the thing I'm trying to find, times T over 100. So what I do now is I rearrange to get R. So I'm going to put in my calculator this, this, and this. Everything but R. So if I put on my calculator 5,000 times 1.5 divided by 100, I get 75, right? So all of the stuff circled in blue equals 75. So my equation is 1,000 equals 75 times R. So now I can calculate r very easily. So I want to get r by itself, therefore I need to undo everything that has already been done to r. So here, on the right hand side, I've multiplied r by 75. So to undo timesing by 75, I divide each side by 75. So r is just going to be 1,000 divided by 75, which is approximately 13.33%. So because I put t in years, this will be an interest rate per annum. So I would need an interest rate of 13.33% per annum for my investment to grow from 5,000 to 6,000 in 18 months. So that's all for simple interest. Let's now look at algebra. When we did algebra the first time, a lot of people were getting tripped up by silly mistakes. And I call them silly because you've done this algebra that we're about to go through in year 7 and year 8. You've just got to make sure you follow the rules. So we look specifically at the distributive law. So that's when you have some brackets and a number at the front like this. So it's called the distributive law because you distribute the thing outside the brackets to everything inside the brackets, and it's a times. So we distribute the 2 to the x, 2 times x, and then 2 times positive 3. Now, what a lot of people were losing marks for in the very first test, they were trying to add things like this, 2x plus 6. This cannot be simplified because 2x is a term, positive 6 is a term. They are not like terms because the first term has an x, the second one doesn't. You can only add or subtract terms if they're like terms. That means you can only add or subtract terms that have the same sequence of pronumerals or letters. So because the first term has an x and the second one doesn't, you can't add them together. 2x plus 6 does not equal 8x. That's what a lot of people were writing in the first test, and it's just plain wrong. Please make sure you avoid that mistake. So the answer, if you were asked to expand 2 outside of x plus 3, is just this, 2x plus 6. That's the answer. Done. Move on. Another problem that people were succumbing to in the first test was that they were forgetting that BIDMAS, BODMAS, whatever you want to call it, also applies to algebraic terms. So if I have something like this, say, what a lot of people were doing was they were trying to do the 3 plus 4 first, getting their answer 7, and multiplying by the brackets. That is not correct. You must do the brackets first, always. So I have to do this part in green first, then I add that answer to 3. So I start off by leaving the 3 alone. I distribute the 4 to everything in the brackets. So 4 times 2x is positive 8x, because this is a positive 2 times a positive 4. And then 4 times by not 1, but negative 1. Positive times a negative gives a negative. So that's my answer so far. Notice the 3 stays as it is, because my first step was expanding the brackets. Now, I see if I can add or subtract like terms. So I have 3 terms. 3, which is a positive 3, positive 8x, and minus 4. So the minus 8x is by itself. It doesn't have any friends. It doesn't have any like terms. But these two, 3 and minus 4, are like terms because they have no pronumeral. So I can add or subtract them together. Now 3 minus 4 is just minus 1. The 8x had no like terms, so I leave it as it is. I don't change it at all. My final answer is minus 1 plus 8x. I can't simplify this any further because minus 1 and 8x are not like terms. Now, sometimes what you're going to have to do is expand more than one bracket and collect like terms. So let's have a look at that. So let's do this last question. So we're going to expand each bracket one after the other, then subtract them, because brackets is first. So I'm going to do this first separately. I'm going to do the second one separately, and then I'm going to add together the terms. So let's do the first part. So I go 8 times 2x, it's always a times, that's 16x. Positive 8 times positive 3 gives me a positive 24. Now I'm going to do the next bracket. So it's not a 4 out the front, it's a minus 4. So I go minus 4 times 7x. So minus 4 times 7, negative times a positive is always a negative. And then I have minus 4 times minus 5. Negative times a negative is a positive. So this will become positive 20. So similar to the last example, I have to collect like terms. So 16x and minus 28x are like terms because they both have an x. So to add them together, you just operate on the coefficient the number's in front of. 16 minus 28 is minus 12. So just have minus 12x. 24 and 20, they are like terms because they don't have any pronumerals. So 24 plus 20 is just 44. Okay, so the final answer to this is minus 12x plus 44. You are done. Move on. Do not try to add minus 12x and 44. They are not like terms. So I'm just going to show you a couple of quick worded problems in algebra, and then we'll move on to the next topic. So let's have a look at this question here, because it's very important that you are able to transform worded problems into mathematical equations or statements, and that's exactly what we're going to do here. So the question, I earn $500 per week plus 3% commission on all sales made over $5,000. If I make X dollars in sales and X is greater than 5,000, what is my weekly pay in terms of X? Give answer in both expanded and factorized form. So since this said I have to give my weekly pay in terms of X, my final answer should have an X somewhere, or I've done something wrong. Notice the question said give both expanded and factorized form. So if I want full marks, I need to answer fully by giving both of those, and I'll show you how to do that. It probably seems a bit scary, but really all we're going to do is rewrite this information as a mathematical statement. So I earn $500 plus 3%, which is 3 over 100, of what I sold over 5,000. So the way I write that mathematically, the amount I sold minus 5,000. If I made $12,000 in sales, for example, then what I've sold over 5,000 is 7,000. I've sold 7,000 more. So that's what is written in black now is exactly what was said in the blue words. I earn $500 plus 3% of what I earn over 5,000. That is my weekly pay. So I'm just going to call it like P for pay. So I want to give it in expanded and factorized form. So this one is good enough for factorized form because I've got factorized form here, even though I have that 500 there. I'll accept that as factorized form. So to expand it, I need to apply the tricks I was just going through. I need to distribute the thing out of the brackets to everything in the brackets. So I leave the 500 alone for now. So I go 3 over 100 times x. So then 3 over 100 times negative 5,000 is the same as 3% of 5,000, which is minus 150. So again, like terms, collect them. And then I leave the one with the x in by itself because it has no other like terms. This is expanded form. So this is a way to calculate my weekly pay. It's 350 plus 3% of my total sales. How easy was that? Didn't take us too long at all. Now we're going to look at the next topic, which is Pythagoras and trigonometry. So again, please pause and copy down if you need this. So Pythagoras and trigonometry were linked together because they're basically very close in what they're trying to achieve. Now, both of them involve right-angled triangles. So you have a triangle with a right angle. We call the longer side, which is always facing or opposite the right angle, we call that the hypotenuse. So for Pythagoras, we label the sides C for the hypotenuse, and the two shorter sides are A and B. Doesn't matter which way around you label A and B, but it does matter that C is the hypotenuse for the formula. So Pythagoras theorem tells us how to find an unknown side, so that's important. We can't find an unknown angle using Pythagoras. We want to find an unknown side in a right-angled triangle when we know the other two sides. So you need to know two sides to use Pythagoras, and that's slightly different than what you need to know for trigonometry. So if you do know two of the sides, we use the formula a squared plus b squared equals c squared. So this number squared plus that number squared equals that number squared in a right-angled triangle. So we can rearrange this formula. If we want to find the longest side or the hypotenuse, you can jump straight to the answer c equals square root of a squared plus b squared. If you want to find a shorter side, so let's say you're finding A, it's the square root of c squared minus b squared. So note, when you're finding a longer side, you plus. When you're finding a shorter side, you minus. And that's pretty logical. So we're going to have a look at a couple of quick examples. So let's have a right-angled triangle like the one I've just drawn. So this one, X, it doesn't matter whether you call it X, Y, Z, whatever, we figure it out the same way. It is going to be the square root of the squares of the two shorter sides added together. So square root of 3 squared plus 4 squared. I'm adding because I'm finding the longest side, and you can put that straight on your calculator and you get 5. So let's look at the next example. So this time we're finding a shorter side. We know that the hypotenuse is always facing the right angle, so 10 must have to be the longest side, the hypotenuse. So we're finding a shorter side, so we just call it A, whatever you want, is the square root of c squared minus b squared. Put that straight on your calculator, and to about 2 decimal places, you get 7.33. So, of course, the answer when you're using Pythagoras will not always be a whole number. So, usually, you can jump straight to the formula. You don't need to show too much working out. There's one exception where you cannot jump straight to the formula, and I'll show you that right now. So the rule that I put up before for finding a shorter side, as we're going to try and do in this triangle, was A equals square root of c squared minus b squared. So normally when finding a shorter side, you can jump straight to this rule. The only exception, the only time you can't do that and you have to write out a full equation, is an example like the one I've drawn for you. When you have an isosceles right-angled triangle, isosceles meaning that two sides are equal, an isosceles right-angled triangle, and you know the longest side. So here I'm going to have to use equations. I'm going to call the shorter side A. They're both equal because the triangle is isosceles. So how are we going to figure this out? We're actually going to have to go through and full use Pythagoras theorem. So I know a squared plus b squared equals c squared. But in this triangle, A and B, the two shorter sides are the same. So I can make that a squared plus a squared. C, in this case, the length of the hypotenuse is 48. So I'm going to change that to 48 squared. So a squared plus a squared is 2a squared. Now 48 squared is 2,304. I have an equation to solve. I have to undo everything that's been done to A. So what I did was I squared A. You do that first because of order of operations. And then I timesed by 2. So when finding A, I need to undo everything that's been done to A in the opposite order to BODMAS. So first thing, I'm going to divide each side by 2. I get a squared equals, now 2,304 divided by 2 is 1,152. So A will be the square root of. The way you undo squaring is square rooting both sides. It'll be the square root of 1152, which is about 33.94. So each of the shorter sides here will be about 33.94 millimeters. So Pythagoras can help us find an unknown side in a right-angled triangle when we know some other information about other sides. It can also help us determine whether or not a triangle is right-angled, because the converse of Pythagoras' theorem holds. So the converse means, so we know that if we have a right-angled triangle, if we know that the triangle is right-angled, that implies that a squared plus b squared equals c squared. That's what we just used to find an unknown side. If a squared plus b squared equals c squared, if you know the three lengths of the sides, and this is true, then the triangle is right-angled. So we can use Pythagoras' theorem to tell us whether or not a triangle is right-angled. Let's say I give you this black triangle here, and I'm going to tell you the side lengths. Let's say that this is 13 meters, 12 meters, and 5 meters. Is the triangle right-angled? That's actually really easy to do. We just check if Pythagoras' theorem holds. Now, obviously, 13 is the longest side in this right-angled triangle. So it's like C, and we have A and B. So we just check, does A squared plus B squared equal C squared? Well, A squared plus B squared, if we put that on our calculator, is 169. C squared is 169. So therefore, we have a squared plus b squared equals c squared. So therefore, yes, Pythagoras' theorem holds, and this will be a right-angled triangle. Let's look at another example. So let's look at this new black triangle that I've drawn up. Is it right-angled? We're told it's isosceles, so it has two sides that are equal length. That doesn't tell us whether it's right-angled or not. You can't just look at it and say, oh yeah, this angle here looks about 90 degrees. Could be 89 degrees, 88, 92. So we need a foolproof way to check, and that's what Pythagoras' theorem gives us. So we just check, does a squared plus b squared equal c squared? Well, we have a squared plus b squared, because they're the same, equals 137.78. But c squared doesn't. It equals 146.41. So in this triangle, a squared plus b squared does not equal c squared. Therefore, it is not a right-angled triangle. So at this stage, in Year 9, we can't tell anything else about that triangle. We're not able to say, is it acute angled? Is it obtuse angled? We can't tell what type of triangle it is. All we can say is it's not right-angled, and that's all you need to know. Now let's look at trigonometry. So, trigonometry also involves right-angled triangles. Now, like Pythagoras, we can use trigonometry to find the length of an unknown side. But when we were using Pythagoras to find an unknown side, we needed the lengths of the other two sides. If you want to find a side using trigonometry, you need the length of another side and one angle. So you can also use trigonometry to find an unknown angle, which you couldn't do using Pythagoras. Now, if you want to use trigonometry to find an unknown angle, you need the lengths of the other two sides. So trigonometry and Pythagoras, they're like complementary. But trigonometry also involves angles. So I'm going to label this angle, random angle here, theta, Greek letter theta. So if I fix theta, if I tell you that theta equals 30 degrees or 20 degrees or whatever, then the ratios of the sides is also fixed. The ratio of this side to this side is fixed. The ratio of this side to this side is fixed. It'll equal a certain number. The ratio of this side to this side is fixed. It will equal a certain number. That is the theory behind trigonometry. So we need to label the sides appropriately for this. So hypotenuse is the same as it was in the previous slide. It is the side opposite the right angle, facing the right angle. It is the longer side of the triangle. The side next to theta is called the adjacent, and the other side, the shorter side that's facing theta, is called the opposite. Now note that if we change the reference angle, the hypotenuse stays the same, but the adjacent and opposite switch around. So if I was talking about this angle here, theta, then this side here would become the opposite, and this side here would be the adjacent. It's really important that we label them properly. So I'm just going to rub that out so we can avoid the confusion. I just want you to know adjacent means the side next to, opposite the side facing. So from this, we get three ratios that you need to know. So the sine ratio, the sine of the angle, is the ratio of the opposite to the hypotenuse. The cos of the angle, that ratio is the ratio of the adjacent to hypotenuse. And the tangent ratio is the ratio of the opposite to the adjacent. So the way that you remember this, the acronym is Sohcahtoa. So it's important you know which ratio is which, because depending on the information you're given, you need to determine whether we use sine, cos, or tan. So let's look first at finding a side. So what we do is we set up an equation, and then we use our calculator to find the unknown side and solve that equation. So let's say I have the right angled triangle in this picture. I have the length of a side and an angle other than the right angle, so I can find another side. So x is on the opposite side, this side is the adjacent, and 2 is the hypotenuse. So the question involves the opposite and hypotenuse. So I know straight away I use sine. So I set up my equation like this. Sine of angle equals, so it's important you understand sine is opposite is on top. O is written first in the acronym, so it goes on top. So it's sine 30 equals x over 2. Now sine 30 is just a number. If you put it in your calculator, you should get a half. Make sure your calculator has this little symbol with the D, so you're in degrees mode. So sine 30 equaling a half means that if I tell you that this angle theta is a half, then the opposite side is half the length of the hypotenuse. So if we know the hypotenuse, we can easily figure out the opposite. So what we do is we solve this equation. So x is on top. We've got x divided by 2 is sine 30. Sine 30 is just a number, a half. So the way we undo dividing x by 2 is timesing each side by 2. That will get x by itself. So x will just be 2 times sine 30, or sine 30 times 2. And if you put that on your calculator, you get 1. Because if the angle is 30, the opposite is half the hypotenuse. That's what this means. So let's look at another example. So let's do this one, and we'll do it in a very similar way. So first we have to decide which ratio we're going to use. So this side was sort of the opposite in the last question, but we've changed our reference angle to this one. So 4 is no longer the opposite side, it's the adjacent side. This side is opposite, this is hypotenuse. So this question involves adjacent and hypotenuse. So adjacent and hypotenuse is ka for cos. So we set up our equation in the same way. Cos of angle equals adjacent over hypotenuse. Now in the previous example, x was on top. If x is on top, you times. If x is on the bottom, you need to divide. Here it's on the bottom. So the answer, x isn't 4 times cos 72. X is 4 divided by cos 72. So make sure you know that. If x, the thing you want to try to find, is on top, you times. If the thing you want to find is on the bottom, you divide. So the answer I got on my calculator is 12.94. So I want you to have a think about, is this answer plausible or not? So note in this example here, x was one of the shorter sides. So I should have got an answer less than 2, because 2 is the hypotenuse. It has to be the longer side. And I did get that. Here, I'm finding the hypotenuse, the longer side. So it has to be longer than 4, and it was in this case. So I know I've done something right. All right, the last thing I need to show you with trigonometry is finding angles. So again, please pause and copy down if you need this. So as I said on the previous slide, if you want to find an angle using trigonometry, you need to know 2 side lengths. And Pythagoras has not much at all to do with angles. You can't use Pythagoras to find angles, you need to use trigonometry. So, we still have the same acronym Sohcahtoa. Still has the same meaning. You use sine if you're given the opposite and hypotenuse, cos if you're given the adjacent and hypotenuse, and tan if you're given the opposite and adjacent. But what's important to know here is we use sine, cos, and tan when we're finding a side, just like we did in the previous few examples. Now, when you're finding an angle, you need to use sine inverse, cos inverse, or tan inverse. That's how you find an angle. So on the black Casio calculators, if you wanted to say use sine inverse, you press shift and then sine. Or cos inverse, you press shift and then cos. So let's look at the blue triangle that I've given you. So let's say first I want to find this angle here, which I'll call theta. So 10 is the opposite side, 12 is the adjacent side. So this question's involving opposite and adjacent, so I use tan. But because I want to find theta, which is an angle, I use tan inverse. So theta is just going to be the tan inverse of the opposite over the adjacent. So if you put that on your calculator, again making sure you're in degrees mode, you should get about 40 degrees to the nearest degree. That's the answer, you're done. So if we know that this angle here is 40 degrees, then this one here would be about 50 degrees, because those two angles must be complementary and add to 90. Okay? But that's how easy it is to use trigonometry to find angles. All right, now we're going to move on to linear relations. So the first thing we're going to do in the linear relations section of this video is go over how to calculate the distance, midpoint, and gradient of a line segment. So remember, a line goes forever in both directions. A line segment has a start point, so I'm just going to make up a random point, and an end point. So we'll start with the midpoint. So the midpoint is the point along the line segment that joins these 2 points that is halfway between those 2 points. Same distance from this point as it is from this point. So the way you calculate the midpoint, pretty logical. You just take the average of the x coordinates and the average of the y coordinates. Your answer is a point, so it needs to be in brackets. You need to have an x coordinate and a y coordinate. Now note the midpoint formula involves adding. Too many people subtracted in the previous test and thus got the answer wrong. So when we say x1, we mean the x coordinate of the first point, and x2 means x coordinate of the second point, and so on. So we're just going to substitute these values into the formula. So the answer will be x1 plus x2 over 2. You do this part separately on your calculator. That is the x-coordinate of the midpoint. And then you do similarly for the y values. You take the 2 y values, add them up, and divide by 2. That will give you the y-coordinate of the midpoint. So you should get minus 0.57. So that is the point on the line segment that joins this point, and it is halfway between the 2 points. We can have a negative, we can have a number that isn't a whole number in the point. So that's all for midpoint. Let's look at distance. So distance actually involves using Pythagoras. So the distance of the line segment. The line segment can be viewed as the hypotenuse of a right-angled triangle. So the 2 shorter sides, how far you go across, the difference in x values, how far you go up the difference in y values. So Pythagoras theorem is it's the square root of a squared, so a plus b squared. That's the formula. Let's use it for the points that we have up there. So it'll just be the square root of x2 minus x1. So I need two minuses here. x2 minus x1 squared plus y2 minus y1 squared. So note it's a plus between the two brackets, but inside the brackets we minus. So we minus when we're finding the distance, but the midpoint only involved adding. So you can put this straight on your calculator. To two decimal places, you should get 7.81. So it's just 7.81 units. That's the distance of the line segment. So to find the gradient, because we have 2 points, we use the 2-point formula. So the gradient, which we usually call m, is the rise over the run. But the rise is just the difference in y values, how far you've gone up, divided by the difference in x values. So what might be confusing here, this one again involves minusing, whereas the midpoint involved adding, but it's the y's that go on top. Please note that, because it's rise over run, not run over rise. So in the previous linear relations test, heaps of people made that mistake. They put x's on top. When you're finding the gradient, y's go on top. So the gradient here will just be y2 minus y1 over x2 minus x1. Again, we need two minuses because x1 was a minus. So if you put that on your calculator, you should get positive 6 over 5. So just so we note, although it wasn't asked to us here, this is a positive gradient. So the line segment would lean to the right. It would lean that way. Let's have another quick tutorial on graphing. So we need to be able to graph linear functions. So I need to be able to give you an equation that you turn into a straight line graph. So there were three methods we used for graphing. So the first was called the gradient intercept method. And hopefully you remember it was called that because we used the gradient and the y-intercept to find 2 points. Then we just join them up. So that's easiest when the equation's in the form y equals mx plus b. When it is in that form, the number in front of x is the gradient, and the number by itself, b, is the y-intercept. So what we do here with this method, remember, is you first step mark the y-intercept. Secondly, you use the gradient to find a second point. Remember, the gradient is the rise over run. Once you've got 2 points, you simply join them up. That's how easy it is. So let's look at an example. Let's say I want to graph the function y equals 3x minus 2. The number in front of x is the gradient. So the gradient's 3 or 3 over 1. The y-intercept is minus 2. So we're going to mark this y-intercept, use this gradient to find a second point, and then simply join them up. A graph, I'm sure, will look much better than mine. I'll just quickly label the axis. Remember, x is the horizontal axis, y the vertical axis. So to mark the y-intercept, I go along the vertical axis, and I'm going to go down here to y is minus 2, and I just plot a point there. That is the y-intercept. Step 1 done. So the gradient 3 over 1, so the bottom number tells you how far you go to the right. The top number tells you how far you go up or down. You go up if it's positive, down if it's negative. So because the gradient's 3 over 1, to get the second point, I go across 1 and I go up 3, which is here at the point 1, 1. So I've now got 2 points, and all I do is simply join them up. And again, yours will look much better than mine. I should label it as well, but that's not really a big deal. Okay, then I'm done. I've graphed using the gradient intercept method. So I won't always be given the equation in the form y equals mx plus b. Sometimes I'll be given it in the form something times x plus something times y equals something. Trying to rearrange it into this form can often be very hard, so we need another method, and that is the x-y-intercept method. So, as the name suggests, all we do is we find the y-intercept. We do that by letting x equal 0. Then we find the x-intercept by letting y equal 0. And then we join them up. Both of these methods have the same idea behind them. You find 2 points that lie on the line, and then you just plot them and join them up. How easy is that? So, for example, let's say I have the equation 4x minus 3y equals 12. It would be very hard to put in the form y equals mx plus b, to put in that form. Way, way, way too hard. Now, note, because it's not in the form y equals mx plus b, the number in front of x4 is not the gradient, and this number by itself, 12, is not the y-intercept. The number in front of x is the gradient, the number by itself is the y-intercept, when and only when the line is in the form y equals mx plus b. So, first step, find the x-intercept, the y-intercept by letting x equal 0. So we take our equation 4x minus 3y equals 12. Now we're going to let x equal 0. So I'm just going to get rid of the x's there. I'm left with minus 3y equals 12. Y is 12 divided negative 3. Second step, I'm going to, again, take my equation, 4x minus 3y equals 12. This time I want to find the x-intercept by letting y equal 0. So I'm going to get rid of the y. The minus belong to the y as well. So I'm left with 4x equals 12. X is 12 divided by 4, which is 3. So I draw up my Cartesian plane again. Now I'm just marking the x and y-intercepts. The y-intercept was minus 4, x-intercept was 3, and all I do is simply join them up. So this is the line 4x minus 3y equals 12. So note, in both cases, the line is leaning to the right. That means it has a positive gradient. So if the gradient is positive, like it was in the first one, your line should lean to the right, or you've done something wrong. So remember, there are some special cases that don't fit either of these methods. So that's when you have x equals a number. When you have x equals a number, the line is perfectly vertical or parallel to the y-axis. And when you have y equals a number, the line is perfectly horizontal or parallel to the x-axis. So if I say wanted to graph, let's try the lines x equals minus 3 and y equals 2. I can't use the gradient intercept method or the x-y-intercept method on either. I mean, these two lines only have one intercept, so that wouldn't work. Use the x-y-intercept method. Now, using the gradient intercept method wouldn't work either. I mean, x equals minus 3, the gradient's actually infinite. It's undefined. So that's why neither method would work. But fortunately, they're very easy to graph. So let's again draw up our Cartesian plane. I know yours will be ruled and look so much better than mine. So we'll label x and y. So for the line x equals minus 3, you just go across to minus 3 and you draw a perfectly vertical line. That is the line x equals minus 3. Okay, so for y equals 2, you do something similar, except you go along to the y-axis. You go up to y equals 2, and then you draw a line that is perfectly horizontal. Now, this line's only correct if this is 2, so it's really important that people label their axes. This caused a lot of people to lose marks last time. So notice in all of my examples, the axes are labeled. So in my first one, we had the 1 here, 1 here. That enables me to make sure that this is the correct line. Because if I didn't put that 1 there on the x-axis, the axis could be going up by 2. So this first dash could represent the number 3. It's only right if you label the axis. Here, when I was using the X-Y-intercept method, I had a label on the X and the Y axis. That means that the line is correct. Here again, I've got my label on the X and Y axis. It is really important you label the axes correctly. So the last thing we need to do for linear relations is find the equation of a line, and I'll now go through that. So there are heaps of different types of questions for finding the equation of a line, but they all use the same method. So what I want you to do is find what the gradient is, then you find what the y-intercept is, which I call b, and then your equation is just y equals mx plus b. They are your steps. What makes it complicated is how you find m and how you find b differ depending on the question. So we're going to find the equation of a few different lines. So first thing we're going to do is we're going to find the equation of the line with, say, gradient 10 and y-intercept 5. Okay, that's easy as. I told you before that the equation of any line can be written as y equals m gradient times x plus y-intercept. So that one is easy as. Now, sometimes you'll be given an equation to find where you're told the gradient. So let's say we're going to find the line with gradient 4, but instead of telling you the y-intercept, I'm going to tell you that it passes through the point -3, 6. Okay? So, again, our first step is to find m, but that's already done for us. We're told that the gradient is 4. So, how do you find b when you're not told it? Well, what you do is you take your equation y equals mx plus b, and what you do is you substitute m. So in this case, m was 4. That's why finding the gradient is the first step. And then you substitute x and y from the point. So the point has an x coordinate, which is always written first, and a y coordinate. So I'm going to change x to -3, and I'm going to change y to +6. So then I just solve for b. So 6 equals -12 plus b. Then I add 12 to both sides. 18 equals b. Once you've found m and you've found b, it's easy as the equation is just y equals mx plus b. So the last example I want to show you is when you're trying to find the equation of a line that passes through 2 points. So I'm going to give you 2 points through which the line passes, and we'll find the equation. So I'm just going to make up a random point again. So I've got -2, 5, and let's say 1, 14. So if I give you any 2 points in the Cartesian plane, there's one and only one line that will go through them. So we're going to find m first. Here, it wasn't told to us, but we can find it using the 2-point formula. M equals y2 minus y1 over x2 minus x1. So in this case, it's y2 minus y1 over x2 minus x1. You should get +3. So that's step 1 done. Step 2 is done similarly to the previous question. We don't know b, we're not told it, so we're just going to take our equation y equals mx plus b. We're going to substitute m for the value that we just found. Now, x and y can come from either point. I'm just going to choose the second point because it has no negative numbers. So I change x to 1, y to 14. 14 equals 3 plus b. We subtract 3 from both sides, and we get b is 11. Therefore, the equation of the line is y equals mx plus b. How easy is that? All right, I'm now going to go on to the final topic we went through this semester, which is measurement. So we'll start off with area. We're not going to put perimeter on the test. So all of the shapes for which we found the area this year were not new. You would have done them in Year 7, Year 8, or both, except for a sector, which is part of a circle. So let's say I want to find the area of, say, something that looks like this. And apologize in advance for my horrible drawings. Okay? So let's say I want to find the area of this shape here. How do we do it? Well, the area of a full circle is pi r squared. Please don't get mixed up. 2 pi r is the circumference or the perimeter of a circle. Pi r squared is the area of a circle. So what we do to find the area of a sector is we find the area of the full circle that has that center. Again, sorry for my horrible drawing. And we times by the fraction of the circle we have. So that is given by theta over 360. So in this case, theta, the angle is 60. 60 over 360 is 1/6. This sector is 1/6 of a circle. So we find the area of the whole circle and just times by 1/6 or divide by 6. So I think the answer you get should be about 13.09. And of course, centimeters was the length measurement, so the area will be in centimeters squared. That's how you find the area of a sector using this formula here. Now, what you need to be able to do is find the area of composite shapes. So that's when you have two shapes added together or one shape cut out of another. So let's look at a few examples. So let's try finding the area of this red shape here. So it's actually a hexagon because it has 6 sides. But it's a pretty weird looking hexagon, and we don't even know how to find the area of a hexagon anyway. So what we do is we divide it into shapes, which we do know how to find the area. So this is a trapezium and a rhombus. We know how to find the area of both of those shapes. So we'll just find each of their areas individually and then add them together. So the formula for the area of a trapezium, which is the first shape, is perpendicular height over 2. H always means perpendicular height. So perpendicular height over 2 times the sum of the two parallel sides. So in this case, it'll be height divided by 2 times the sum, of the two parallel sides. So you just end up with 52 meters squared. So the area of the second shape. So the second shape is a rhombus. Note that a rhombus is a type of kite, so we use the kite formula. You times the two diagonals together and divide by 2. This 6 has nothing to do with the area of the rhombus. So the area of that rhombus is just going to be the two diagonals multiplied together, divided by 2, which is 36 meters squared. So therefore, the total area, we just add the 2 up. 52 plus 36, which is 88 meters squared. How easy is that? So that's an example of when you have two shapes added together. Sometimes you will have two shapes where one is cut out of the other. So let's say I want to find an area, a shaded area here. This is actually called an annulus, where you have like a circle cut out of another circle. So I'm going to tell you that this part here is 20 centimeters. And let's say that part in there is, let's say, 3 centimeters. Okay, so the area of this whole shape will just be the larger circle, this time minus the smaller circle, because we've had a shape cut out of another shape. So the area of the larger circle is pi times r squared. Now, 20 centimeters is not the radius. It is the diameter. So the area will be pi times 10 squared. So that is the area of the large circle minus the area of the small circle. So 3 is the radius. This time I don't need to halve it. So I'm going to put this all on my calculator in one go. I don't want to find this, then round it, then find this, and round it again because my answer will be slightly inaccurate. I'm going to put it on my calculator just like this. And if you do that, the answer you should get to 2 decimal places should be 285.88. Of course, our units are centimeters squared. So that's how you find the area of composite shapes. Just divide it into smaller areas that you do know, and you either add or subtract them together. So the last thing I need to go through in area is converting square units, which still seems to be causing us a problem. So we know that when we're talking about area, we're talking about square units of length. So we have millimeters, centimeters, meters, and kilometers. So by now, hopefully you know that there are 10 millimeters in a centimeter. So going from millimeters to centimeters, you divide by 10. When you're going from a smaller to a larger unit of measurement, you divide because there are fewer of the larger unit of measurements. There are fewer centimeters than millimeters. So there are 100 centimeters in a meter. So you divide by 100, and then there are 1,000 meters in a kilometer, right? So when you're going the other way, it's the same number, except now we're timesing. If you're going from a larger unit to a smaller one, you times, because there are more of the smaller unit. So you can follow this chart for converting square units. So these are units of length. So when we're talking about square units, everything needs to be squared. So we need to square the tens, the hundreds, the thousands on both sides. So there are 10 millimeters in a centimeter. There are 10 squared, which is 100 square millimeters in 1 square centimeter. So why is that? So let's draw up a square here. And we're going to say that that square is 1 centimeter by 1 centimeter. So shocking, I know, its area is 1 centimeter squared. Right? Area of a square is easy. Just side length times itself. But 1 centimeter is 10 millimeters. So this square is 10 millimeters by 10 millimeters. 10 millimeters across, 10 millimeters down. So its area will be 10 times 10, which is 100 millimeters squared. So 1 centimeter squared and 100 millimeters squared are the same thing. So I could have used a similar argument for centimeters and meters. 1 meter squared is 100 centimeters across by 100 centimeters down. Therefore, there are 10,000 square centimeters in a square meter. That's why you need to square the conversion factor when converting units of area. So we're now going to go on to surface area. So the surface area is of a 3D shape, and we call it TSA for total surface area. It's just the sum of the areas of all its faces. So let's look at an easy example first. Let's look at a rectangular prism, and I will apologize in advance for my drawing. So the total surface area, we just find the area of each of the faces. There are 6 faces of a rectangular prism, and we add them together. So we have like the bottom of it and the top. Both of them are rectangles that are 6 by 4. So there's 2 rectangles that are 6 by 4. So then we sort of have like the front and the back. Both of them are 5 by 4. So we've got to add on 2 lots of 5 by 4. But there's also 2 rectangles on the sides. So we have this side here, this one here. So that is a 6 by 5 rectangle, and we have the other side, which is also 6 by 5. So we need to add 2 lots of 6 by 5. So that's how we get the formula for the total surface area of a rectangle. It's 2 length times width, plus width times height, plus 2 length times height. It doesn't matter which of the 3 dimensions you call the length, which you call the width, and which you call the height. You do things the same way. So if you put all that on your calculator, you would get 148. Now, the units for surface area are the same as for area, so it'll be centimeters squared. So what you can think of is that if I wanted to wrap a rectangular prism with these dimensions, 6, 4, and 5 centimeters, if I wanted to wrap it up, I need 148 square centimeters of wrapping paper to achieve that. Now, what makes surface area complicated is that you can't just rely on the formula, because sometimes the same prism will have a different surface area. How can that possibly be? Well, it depends whether the prism is open or closed. So when I found the surface area here, I assumed it was closed because I added all of the faces. But what if I had, say, this was a box and I didn't have the top? Let's say the top was open. Well, I couldn't just use this formula here. I would have to make sure I don't include one of the 6x4 rectangles. I don't include the top. So if it was an open one, it'd be pretty much the same. I have my formula. This is what I had before. 2 times 6 times 4 plus 2 times 5 times 4 plus 2 times 6 times 5. But this time, I don't want to include the top, which is 6x4. So I'm going to need to change this to a 1. And that would change my area to 124 centimeters squared. So it's important you know whether the thing is open or closed. So another shape that we learned to find the surface area of was a cylinder. And again, I'm going to apologize for my drawing in advance. So a cylinder is basically like a circular prism. Okay, so a way that you can help yourself find the surface area of a shape is by drawing a net. So a cylinder is a 3D shape, but if you flatten it into a 2D shape, you end up with a circle at the top. The curved surface is actually a rectangle, and you have another circle down at the bottom. So to find the surface area of a cylinder, I just need to find the surface area of, the area of the two circles, and then the area of the rectangle. So the area of the rectangle, it has the same height. H just means perpendicular height of the actual prism. So that's the length of the rectangle, and the width of the rectangle is equal to the circumference of the circles, 2 pi r. So the total surface area of a cylinder, using the net there, we've got two circles, each has area pi r squared, and then the rectangle is width times length. So this is the formula for the surface area of a cylinder. So again, if it was an open, that's assuming it's a closed cylinder. If it was an open cylinder, we would need to change this to say a 1 and not include the top. So let's look at a quick example. So let's say I have this cylinder here, and let's say its diameter is 18 centimeters and height is 25 centimeters. So we don't need the diameter in the surface area, we need the radius. So if the diameter is 18 centimeters, the radius will be half that and 9 centimeters. So the total surface area will be 2 times pi times radius squared plus 2 times pi times radius times height. And if you put that in your calculator, the answer you get, again, I'm just going to do it to 2 decimal places, should be about 1,922.65. Again, because all the lengths were given in centimeters, there's in centimeters squared. So I've shown you the surface area for a rectangular prism and a cylinder. I wasn't going to do a triangular prism. You don't want to try and learn the formula for that because it's too complicated, and there's a different formula depending on whether it's isosceles or not anyway. So if you want help finding the surface area of triangular prisms, just email me and I'm more than happy to help you. But I'm not going to go through it because this video is taking a very long time as it is. But for a triangular prism, you just find the area of the two triangles at the front and the back. Then you add the area of each of the 3 rectangular faces. You just find the area of each face and add them together. So the very last thing I need to go through is volume and capacity. So volume and capacity are essentially the same thing. They differ in only their units. So volume uses similar units to what we've gone through. We've got millimeters, centimeters, meters, and kilometers. So remember, if we wanted to go from millimeters to centimeters, we divide it by 10, and then we divide by 100 to go from centimeters to meters, and divide by 1,000. If we're going from a smaller unit to a larger unit, we divide because there are fewer of the larger unit. Now, if you want to go the other way, you use the same numbers, but instead of dividing, you times. So remember when we were converting square units, we had to square everything. When we're converting cubic units, we need to cube everything. So for example, there are 10 millimeters in a centimeter, so there are 10 cubed, which is 1,000 millimeters cubed in a centimeter cube. So how do you convert between units of volume and capacity? Well, 1 centimeter cubed actually is a milliliter. That's what a milliliter actually is. 1 liter, you probably already know, is 1,000 milliliters. So, if I have a meter cubed, how many centimeters cubed is that? Well, that would be 1 times 100 cubed. So, there are 100 centimeters in a meter. There are 100 cubed, which is 1 million centimeters cubed in a meter cubed. So, because a centimeter cubed and a milliliter are the same thing, 1 meter cubed is also 1 million milliliters. So to go from milliliters to liters, I just divide by 1,000. I can just cross off the last 3 zeros. So 1 million milliliters is 1,000 liters, which is the same as 1 kiloliter. I don't really mind that much if you don't fully know what a kiloliter and a megaliter is at the moment. So 1 meter cubed is a kiloliter, is 1,000 liters. That's how you convert between units. Now let's look at actually calculating the volume and capacity of a prism. So the volume of any prism, we use AH. So A is the area of the base, and H again is not just the height, but the perpendicular height. H always means perpendicular height in this topic. So let's look at an example. So this is a similar shape to we had before. It's a cylinder and it's got the same dimensions as it did before. So people generally find finding the volume much easier than finding the surface area. One thing that makes this a lot easier is that we don't have to consider whether the prism is open or closed. It's the same volume whether it's open or closed, whether there's a top on this or not. So this cylinder is basically a circular prism. So the area of the base or the cross section is a circle. So the area of the base is pi times radius squared. So that's how I get my A. And I times that by H, the perpendicular height. So the volume of this prism is just going to be pi times radius squared. So again, radius is half the diameter, times the perpendicular height. So if I put that on my calculator, I get about 6,361, this time I'm just going to do 1 decimal place, 0.7 centimeters cubed. So it's centimeters cubed because the units of length were in centimeters. So this is the volume of the prism. So its capacity is going to be similar, just different units. So remember, a milliliter is the same as a centimeter cubed. So if the volume is 6,361.7 centimeters cubed, the capacity is 6,361.7 milliliters. And you divide by 1,000, you get in liters. So it'll be about 6.3617 liters. That's how much liquid it would hold. Okay, let's just do the volume of a different shape now. Let's do a triangular prism. So let's find the volume of this triangular prism that we have here. Yes, it's not a cylinder, but it's the same process used to find its volume. We find the area of the base, and then we multiply by the height. That is how you find the volume of any prism, and this is clearly a prism. So, area of the base, so the base is the triangle. Just take the base of the triangle times its perpendicular height over 2. So that's the area of the base. And then we times that by 16, which is the perpendicular height. So if you put that in your calculator, you should get 768. This time it's in meters cubed. So note, this 10 had nothing to do, this 10 here had nothing to do with the volume calculation. You would need it to find the surface area, because if you're finding the surface area, you would need to find the area of that rectangle. The 10 has nothing to do with the volume calculation. So, the volume is 768 meters cubed. So remember, 1 meter cubed is 1,000 liters. So this shape, this container, object, whatever you want to call it, would hold 768,000 liters, or 768 kiloliters. So that's obviously very big. So the very, very last thing I want to show you is an example of where you're solving a problem using the formula we have for measurement. So let's look at this question here. I want to make a can in the shape of a cylinder that holds 375 mils. If the radius of the can is 3 centimeters, what would be its height? So, because I'm told the can holds 375 mils, I am being told about its volume. Milliliters is capacity, which relates to volume. So, this is true for any similar question in the topic of measurement. If you are asked to find the dimension of a shape, like its length, its width, its height, or whatever, you follow the same process every time. You use the formula to set up an equation, then you rearrange that equation, you solve for the unknown. So that's what we're going to do here. So the volume of a cylinder is the area of the base, which is pi times radius squared, times the height. So now we substitute in everything we do know. We want the volume to be 375 mils. Note, 375 mils is the same as 375 centimeters cubed. They are legit the exact same thing. So 375 volume equals pi times radius squared times height. So we have an equation with an equal sign. We want to solve for h. So this is exactly how you would do it. If, you know, we're doing an area problem and you had to find the unknown length of a trapezium or something, you'd just be using a different formula. You substitute in everything you do know into the equation and rearrange it. So let's do that here. So I've taken h and I have timesed it by pi times 3 squared, or 9 pi. So how do I get h by itself? Well, I undo timesing by pi and timesing by 3 squared by dividing by them. So h would be 375 divided by pi times 3 squared. And I just put that on my calculator. So the answer I get, this time I'll give it to 1 decimal place, is about 13.3. Now, because everything was in centimeters, then this will also be in centimeters. So the height of the can would need to be about 13 centimeters. So again, that's how you use measurement formula to solve for an unknown dimension. You take the formula, set up an equation, substitute everything you do know, and rearrange the equation. All right, we're finally at the end of the video. Sorry it was so long. There is a lot to learn, but there is a lot of help out there. Please email me if you want any more help whatsoever. Best of luck studying. This has been the luckiest maths teacher in the world. Have a great day.